Hello, everyone. So welcome to this talk. Today we will talk about the latest updates in 4.1 release. I'm Xiao Li, and the DB and I basically work for Databricks and a long-time Spark committer and PMC member. Spark 4.0 was released 2 weeks ago. This is a major milestone for the community. It contains over 5,000 resolved JIRAs, and there are more than 400 contributors for this release. So this is a huge community effort. The release sets a foundation for the 4.x line. So thank you, everyone, for contributing to this release. So Spark has almost 50,000 commits and 880,000 code review comments. So this is a decade of sustained growth. So community are from the different countries. The diversity keeps the Spark relevant for every use case. And the PyPy also shows PySpark was downloaded in 214 countries and regions last year, and the Spark is everywhere. So monthly PyPy downloads and Maven downloads, this is just open source PyPy and Maven, now tops the 93 million. So basically, many companies, the production relies on the Spark everywhere for data processing. So all these community efforts fit into Spark's mission to be a unified analytics engine. One platform that handles batch, streaming, SQL, ML on any data source, in any environment, like on-prem, cloud, Kubernetes. So these principles guide our roadmap for 4.x. So Spark Kubernetes Operators is now an official sub-project of Spark, native Kubernetes management for Spark. So we have released 3 versions this year. Spark 4.0 added a Python data source APIs, so simple to use. So we can even also generate the data source with AI. We'll show an example later. Previously, writing a custom data source required Scala, Java expertise. So data source v2 is complicated, so many APIs, performance knobs. So this data source API, Python data source API, opens a door for a larger community to build connectors, since you can do it in PySpark without diving into the JVM. So, the community this year already implemented many data sources, for example, LensDB, Google Sheet, Excel, Hugging Face, GitHub. Please contribute to your data source. Spark 4.x delivers a lot for Python developers. In 4.0, native plotting, now you can visualize the data frame directly. And the data source API I just mentioned, and also streaming, like arbitrary stateful processing v2 API. And also we integrate PySpark or Spark ecosystem with Arrow. With this UDF applying Arrow, and you can also convert your data frame to Arrow, then you can directly use this Arrow library with Spark. And also the PySpark binary image now has more than 400 megabytes, so it's pretty big. So that's why with the Spark Connect technology, we introduce a lightweight Python client, just like 1.5 megabytes, very tiny, very small. You can install, deploy it everywhere, like your mobile. In 4.1, we'll talk about this release in this talk. Like for example, declarative pipeline, template table, UDF debugging, real-time streaming. We also continue to optimize the Python data source, like column pruning and predicate pushdown. So we can get better performance using the Python data source. Spark 4.0 also made major improvement for SQL users. Like we turn on ANSI by default. So Spark SQL behaves closer to standard SQL, like stricter type checking, error invalid data, and improved correctness. And the UDF, UDTF, actually is this very popular feature, SQL features in Databricks. Almost all the Databricks customers are using this. So we open source it in 4.0. And also many other SQL features like correlation, second variables. Yeah, you can try the 4.0. And the Spark 4.1 will focus on the SQL enhancement tool, like for example, declarative pipelines will be also available in the SQL. So that means actually we added two important features with the declarative pipeline. One is streaming table. So that means you can run streaming using SQL syntax now with declarative pipeline. And materials view. So that's also very popular features community is asking. So in the 4.1, we will start the support of the materials view. And also scripting, SQL stop procedure, recursive CTE, many new data type, for example, time data type, spatial geo data type will be also available. And with Spark Connect, the Spark driver is now decoupled with from the client. So any language like Scala, Python, Swift, Go, Rust can talk to Spark. So now you can choose any language you like. 4.0 delivers many features across syntax, streaming, connect, usability. I don't want to repeat this. Tomorrow, Daniel and Wenchen will give talk about the 4.0 release. So now these talks will focus on the 4.1 features. I will cover the first three, and DB will cover the remaining three. Declarative pipeline. I believe most of you already use Spark to write some data processing pipeline. Normally it's the imperative. You can see you basically read some table. For example, here it's using streaming, and then you do some filter, generate another table, and write to this second table, table 2. And also you can write other filters and write to the table 3, then join the table 2 and table 3 together, okay, and write to the table 4. But this actually is pretty painful. If you look at the code, you will figure out, oh, the table 2 and table 3 actually can be executed in parallel. They don't have dependency. However, for many users, I saw they just run it sequentially. Some people just ask, oh, can we just run multiple cells at the same time in the notebook? Actually, notebook is hard to tell whether this the two jobs or two execution have a dependency. So that's why it's a common pain. So when you build a pipeline, it's complicated. Coordination, you need to consider the schema mismatch, and also you need to handle dependency. The table, the job could change, right? Semantic could change. So you also need to basically handle airflow, DBT, this external tools. It's complicated. So, this example basically shows you have to explain how to do it step by step with the very details. This is painful and hard to maintain. However, at the same time, we can use a declarative way to describe how to achieve that, right? Just need to tell what to achieve, what to do. So SQL API is a typical declarative API for people. In Spark, in the past 10 years, basically at the very beginning, we provide the RDD API, dstream API. This is imperative API. And then later, to make Spark simple, we introduced the data from API, SQL API, search streaming, and made Spark user happy. However, can we extend the Spark declarative model from individual queries to entire query plan? The answer is yes. This release will introduce the Spark declarative pipeline. Tomorrow, Michael will announce this in the keynotes. And so basically, the idea is simple. We just, instead of specifying every step, we just specify the entire pipeline up front. And then you execute it with one command. Spark will take care of figure out the execution plan for the whole pipeline and schedule these parts of the pipeline in correct order, parallelize them if possible, handle streaming, batch execution details for you, all automatically under the hood. Spark native, that means this is part of Spark. This is the new components. You use a Spark API, Dataframe API, SQL API, and taken to the high level, Spark will handle all the optimization infrastructure for you. So then, so starting from 4.1, we hope we can provide a Python and SQL first. In the future, we can provide more API based on Spark Connect. Like I just mentioned, any language you can choose. The second part is a pipeline runner. So this is the new concept, new component we introduced for the SDP. So this will take the pipeline definition, actually execute it. So you can think of this is extension to the Spark scheduler or optimizer. So this will operate at the pipeline level. It will analyze all the declaration definition you define and determine the correct execution plan. And the runner will start stream run the transformation, ensure things happen in the right order automatically. So basically, it's doing the job that we are human are doing that at that time, manually at this moment. So here, just as the Python examples, you can here just like define the customer table. Not table, it's like a query. The title is a customer, read from the CSV file. You define another like a table, orders, read stream from the Kafka. And then you join them together and define another fact orders. You don't need to execute, you just need to define them. Then you run this command, Spark pipelines run. Spark will handle all the details for you. SQL, you can do the same thing. Create streaming table from the Kafka, create method view for the CSV files, then you join them together. And under the hood, Spark will feed out automatically for you. Handle parallelism, ordering, validation, and you just need to, you can choose two different, the execution mode, like a batch or continuously. So compare with, maybe you also use the DBT. We can compare this to, they're similar. So DBT basically focuses on SQL. SDP will focus on the Spark. Of course, you can also like push down the SQL to the underlying data cells, like SQL data cells via JDBC connectors. You can define the subquery, push down the whole query to the underlying SQL warehouse. And the language, it supports the Python, SQL, and more language in the future. DBT focuses on the SQL. And the data processing, we can support the batch, streaming. DBT basically focuses on the batch. And our primary users, data engineers, and the DBT is analytics. Okay, so tomorrow, we'll have 2 talks for DBT. So Michael and Sandy will show more details. If you are interested, please join. Okay, let's talk about streaming. Streaming jobs is pretty popular. It grows 60% year over years. And so we want to introduce a new execution mode, real-time streaming mode. It can achieve like 100 milliseconds. So it's like ultra low latency for the operational like use cases. So if you use a micro batch, it can in most cases, it only can handle streaming, ingestion, and ETL. Now, Spark can provide both. You don't need to run other engine for this real-time streaming use cases. For streaming users, no API change. What you need to do is just change the trigger from the processing time trigger to real-time trigger. That's it. It's very simple. Based on internal benchmark, it is 20 times, 30 times faster than micro batch. The high-level ideas are simple. They're scheduling all tasks with dedicated slots, and they reserve that capacity for a much longer period of time, and then not a typical micro batch that consistently get executed. So we enable data to flow, so the built-in operators and your customer code and send the computed results to downstream immediately. So this is a longer batch. Basically, it's a micro batch mode breaks the streaming into micro smaller batch, right? Coordination, scheduling, sequential execution. But the new modes, so new data must wait until the current micro batch to finish before being processed. So it causes a latency flow. In real-time mode, all stages can execute concurrently in a continuous pipeline. So tasks persist all across the time. This eliminates the stop and the go batch overhead and significantly reduce the per record latency. We also introduced streaming shuffle. So that means intermediate results are pushed directly to downstream as soon as they are produced, instead of waiting for entire upstream stage to complete. So this non-blocking streaming enables records to propagate through the processing pipeline in near real time. So fault tolerance, we keep the same fault tolerance. So offset our checkpoint only at the end of each long-running batch. So if a failure occurs during the batch, the entire batch is retried from the last committed offset. So no data is lost and skipped. So real-time streaming is 10 or 30 times faster. Micro batch still wins for the throughput and the cost when the sub-second latency is not needed for your use case. So there's many use cases for the real-time mode. And of course, at this moment, real-time streaming still has a limitation. It only supports stateful operations, at least once Kafka for each thing. We'll expand, we'll improve the support. So we also have a streaming talk. Please join. There are 2 talks about streaming, real-time streaming. Okay, Gen AI. Now how Gen AI changes Spark development. 92% of US developers already start use or plan to use AI coding tools. So ARM is good at coding. 2023, people are using documentation, overflow, Stack Overflow. 2024, ChatGPT helps. ChatGPT reduce the time efforts for the users to write the Spark code. But in the future, actually IDE agent can write the Spark code for you and call runtime API directly. So we are trying to figure out what we can do to improve this code quality. So first is, how about a new feature, new API? We need to produce a Spark code, high quality Spark code. We need to improve the documentation, examples, error message, and machine learning, for the machine to read, to pass. So here, we just example, we just mentioned the Python datasets, right? If we directly ask ARM, actually the code that cannot run, just very, the message, API, everything is wrong. So, but however, if we provide examples, this repository contains 10 different Python datasets, actually, ChatGPT, this ARM can generate very good code without errors. It's amazing. Please try it offline. So at the same time, we're also trying to figure out how can we improve the debuggability of the Spark. I know it's very painful for everyone, including myself. Actually, yeah, AI agent can write a good code, right? Can they debug for you? Spark has many internal structure, states, metrics, logs. So how can we provide this information to AI? Spark UI is designed for experts, not for AI. So we need to figure out how to expose this to the AI. So this is still ongoing. And also, we want to improve our release. Current release is too slow, 6 months, 1 year, 2 years. We need to speed up. So we want to introduce monthly preview build for early adopter, people can provide the feedbacks directly. And also, we want to minimize behavior change for API. So AI can generate the code better. Of course, if we want to change behavior, we should document all these behaviors. Okay, DB. DB will continue to introduce the remaining features.
Yeah, thank you. Xiao. Yeah, so my name is DB. I'm going to talk about the rest of the stuff in the slide. So I'm going to cover data source, some of the new foundation, and also some of the SQL feature. So what's the data source API? So in Spark, the data source API is an interface where we enable Spark to read data or write data to external data source, right? So some example can be like a Parquet, CSV, JSON, Delta, Iceberg, JDBC, all of them are like a data source. And this is an interface where we interface with Spark and the external data source. So everyone know that DSV1, DSV2, there are a lot of new investment in DSV2, but we need to ask a question, right? Why DSV1 has a problem, and why we are making investment in DSV2? So when we design the DSV1, we don't have enough good abstraction over the API. So basically, the data source implementation will rely on a lot of the low-level APIs such as SQL, context, RDD, and this leak out some of the Spark internal implementation to the connector. And this is really difficult for different data sources to have a consistent implementation of behavior, like a SAFE, DML, CDC, or store procedure, right? So different data sources can have a different implementation, different behavior, and it's really hard to unify. And it's also hard to evolve. And also in DSV1, there's no catalog support. So we don't have also support for the structured streaming. And we also miss a lot of important DML features like a delete, update, merge, and also some of the optimization, optimize write. So also have some other limitation we're gonna talk about. So what's the current DSV2 situation right now? So currently, DSV2 is getting more and more traction in the data source developer. It's moved a lot of complexity from data source implementation into Spark, so that the connector just need to implement the interface and they can get a feature. It's really reliable. And it's enable more powerful feature like a catalog, federation, a merge, delete, update operation, some kind of like a new feature like a storage partition join. So yesterday I met friends from Meta Spark team actually. So they talked to us and they don't use Iceberg, they don't use Delta, they have their internal catalog. And they want to implement DSV2 API so they can use storage partition join. Right? So as long as they can implement this API, they can automatically get a lot of new feature in data source V2. And in DSV2, we also support aggregation, push down, store procedure. Right? So it's intended for Spark user and developer to work on like a custom or like of the shared like a data source. And it's also right now the foundation of how Spark and Iceberg being integrated. So let's talk about like why we want to work on DSV2. So how many people here are using Iceberg? Okay, there are quite a bit. And how many of you are our customer using Delta? Okay, half of them. So why do we need to make a decision like which format is better? They both use Parquet, but they have a different metadata layout and different feature, right? So right now, one of the ideas people were talking about is that we can have some kind of translation layer where we can translate the metadata, but we keep the Parquet file listen so that you can use Iceberg reader to read data table or using data reader to read Iceberg table. But the challenging is that the translation, although it's possible, but because data is mostly on DSV1, Iceberg mostly on DSV2, there are a lot of different features available in different environments, right? And also some of the behavior can be different. So the goal here is that we want to invest in one set of the data source API, like data source V2, so that we would be able to unify data and Iceberg in terms of the feature. And then we don't have to, choose which format is better, because they're gonna provide the same feature and the same performance. So currently, we believe DSV2 is the future standard of the data source API in Spark. And now we are working on many DSV2 features and for like unification. So we are able to support both data and Iceberg. And also those work can benefit Iceberg as well. Okay, so a couple features like we are working on right now. So default value is one of them. So you can create a table and then with default value, or for existing table you can add a default value. So one of the use cases is that for existing table, maybe you want to add a new column, but you don't want to modify the data, so you can add a default value. So all the existing all data can have the default value. So it's one of the use cases, and I think it's available already in Delta, but not available in Iceberg. So by adding this API into DSV2, we can allow Iceberg also having this feature. And another feature we are working on is check constraint. So it allows user to add constraint on the table. For example, you can say, you add a constraint like price is larger than 0, for example, right? And what's the benefit of adding constraint? This can help, not only ensuring all the data insert into the table, have this constraint, but also the constraint can be used by the query optimizer to help the query performance. And we can also alter table and add a constraint. And it's automatically gonna trigger a job run to check whether existing data can validate with this constraint. And in DSV2, we are also working on a CDC which can use to capture the low-level changes. So it allows people to do incremental consumption. It's a basic building block for the materialized view refresh, and it can also help to improve the efficiency of the data replication. So a lot of new features can build on top of this. And in 4.1 CDC, we plan to support insert, update, delete, tracking, and also it's going to be available for both SQL and dataset API. And it will be working for both streaming and batch mode as well. And it's going to be a consistent CDC interface between data and Iceberg in Spark. Okay, so we're going to have more features being added in DSV2, and it's one of the active areas we are working on. So there's a talk yesterday dedicated to DSV2 in Apache Spark. But there's a recording, so if you are interested in, feel free to watch it offline. And I want to talk about a couple new data types being added into Spark 4.1. That will be added into Spark 4.1. So one of the data type is geo data type. And people are asking that, in Spark, we don't have native geospatial support. And because of that, there's no spatial geo support optimization in the SQL. And this makes user really difficult to handle the geo data, right? Because for example, if you want to search a burger place near me in 5 miles, how can you do it in Spark SQL? There's no way you can easily do it. And there's no easy way that you can have a metadata in Parquet or different format where you can give you the boundary of the data set in terms of the geolocation. So in Spark 4.1, we are going to address the issue. And this is based on the Parquet and Iceberg community. We decided to standardize how we can store geodata type across different formats, and including Delta. So this unlocks the opportunity for good performance because we can store the bounding box statistics inside the Parquet format where the query engine can utilize for better optimized filter condition and also determine which law we have to evaluate in the query. And it would be the full compatibility between Iceberg and Delta because both of them were based on the Parquet implementation. And this alignment is not only on the storage side, we also need to have alignment on the engine side. So Parquet community, the Iceberg community passed the vote to add a feature, and Spark also did that just a couple weeks ago. There's a PIP in the community. And we are going to support like a native geotype in Spark as well, and also Spark SQL. So this is a really good milestone for cloud geospatial ecosystem for many of the new use cases. And because of Spark is able to add this new data type, so we will have a good Spark SQL integration. It can be used as a native type in Spark SQL data frame, dataset API, PySpark, you named it. And we also plan to add a couple minimal set of the SQL function that you can operate on top of those new data type. For example, like a conversion between different geotype. Special query, for example, like ST-box 2D that can return a bounding box of the geometrics, or something like ST-box intercept that can return if it's true if two boxes overlap, right? Like aggregation. So those are like basic building type, building block for the geospatial handling. And those functions will be focusing on like I/O and basic geo indexing. So for more complex use case, people can use like external library or write their own logic to achieve the functionality. But we will be able to provide basic functionality, and the data type is the standard geo data type. Okay, so it's the geodata type. So it's pretty standard, and people can do insert and use it. And this is one example that you can do special join, join like two geotype. Okay. So yeah, so there is a talk about geo, and it's yesterday. So feel free to watch the video offline. And we are also adding a new data type called time. It's a new SQL standard, and we will be support like hour, minute, and this data type. We are time zone, and the basic use case is that for people to migrate from different data type, different database to use it, and it's an expression of the time of the day. So I'm gonna run it faster. And another type we are adding in Spark 4.0 is a variant type. It's really important. So how many people using JSON over here? Yeah, so it's really slow, but people need it because people want to have more flexible schema in JSON inside Spark. And people sometimes have a use case where different rows have different schema inside the JSON. So now we have a replacement. It's called like a variance type. It's already supported in Parquet, supported in Spark 4.0. So the schema can be different by different row. And it's really useful and really flexible data type. So here is a benchmark. Comparing JSON and variance is 8 times faster because variance is a binary format. It's easier. You don't have to parse it. Parse the JSON. Unlike a JSON, we don't need to parse it. So it's extremely fast. And in Spark 4.1, we are going to support variance shading. It's going to make it even more faster because of the certain pairs of the data can store in a separate column. So we will be able to support like min-max statistics, data pruning, and also it requires less I/O and less CPU to read it. It's kind of like native data type, equivalent to the structural relational type in Spark 4.1. So super excited about that. And in Spark 4.1, we are also going to support 10 table. It's an internal feature we're gonna public review in Databricks pretty soon, but we're gonna open source it. So it's useful for supporting the intermediate computation result, and also it can be automatically dropped at a session when the session is finished. And it's created on demand by the user and the application. So the benefit is self-cleaning, is session isolation, and also no ACL is required. So you don't need to have a permission to create a table, but you can just create a 10 table where you can put data over there. So here is one example. You create a 10 table, you insert a couple record into the 10 table, and once the session is finished, the data will be automatically cleaned up. So you don't have to pay for that. And CTE. Databricks supports CTE for a really long time. And how many people are using CTE over here? Quite a few. And how many people want to use recursive CTE? Okay, there are a couple of them. And good news is that Spark gonna support recursive CTE. So I'm gonna skip this one. So a recursive CTE is a special type of CTE where we can have some kind of repeat process, defined it in the CTE. So recursive CTE has two parts. One is the base case, and the other is the recursive part. And they can be union to combine the data result. So an example is here. So here the base CTE query is select one. So you get select one, and you have a recursive query, and then you have a termination condition where n smaller than 5. So then you print out 1, 2, 3, 4, 5. So it's really useful when you need to traverse a data set, a hierarchical data set, and then the query can be implemented by recursive CTE. So before this feature, many people implement this using like PySpark or Scala code, and it's no longer needed. So you can just use a recursive CTE to implement. Okay, this is another. Okay, and then SQL scripting and store procedure. So until recently, if you want to write some complicated data processing logic based on conditional statement and looping, you need to use Python. And now we are introducing SQL scripting, and we're gonna make it open source as well. So in the SQL scripting, we are supporting like a compound statement and local variable. There's a control flow support as well. So let's go into the example. So over here, you can set up some local variable, and you can write a condition, and you do a looping over here. So it's really useful so that you don't need to use Scala or Python code anymore. You can write a lot of control flow code directly inside SQL. Okay, and store procedure. So it's another new feature we are introducing. So the motivation is that store procedure is a named precompiled SQL statement stored they can accept parameter, return some result, and also call repeatedly. So I think the benefit of doing store procedure is that you can store it as a separate unit in the UC or HMS, and they can be secure. You can encapsulate your business logic inside a store procedure, and it's reusable. So it's one example. You can create a store procedure, get customer order, you can have a parameter, and this core logic will be stored in UC or in HMS or other environment and can be reused. So we will be available to reuse the code encapsulate and also improve performance and also enhance better security. Yeah, so there is a talk about all the SQL building block tomorrow on Thursday. So please attend it if you are interested. Yeah, that's it. Thank you.